Your radio telescope just caught something that should not exist. A signal 30 times louder than the universe's own background hum slams into the receiver. It lasts exactly 72 seconds, then vanishes forever. For exactly 72 seconds, a radio telescope in Ohio recorded a signal so powerful and so precise that nearly 50 years later, no scientist on Earth can definitively say what sent it. One word gets written in the margin: wow. That single word now anchors one of astronomy's most stubborn mysteries. August 1977 fills the observatory with heat and the smell of hot ink. Jerry Ehman flips through page after page of raw sky noise. The paper stretches across the desk in endless columns of numbers and letters. His pen stops over 6 characters climbing sharply off the page. The sequence reads 6EQUJ5, a code hiding an intensity spike far beyond routine. Paper this thin carries a discovery heavy enough to outlast its author. Red ink circles the anomaly within seconds. That circle still exists on the original printout today. You can picture the room around him without much effort. Fluorescent light buzzes overhead against a cramped ceiling. Machines hum steadily, feeding endless strips of data into trays. Dust settles on shelves stacked with older printouts nobody has time to file. Ehman's shift feels ordinary until that single line breaks the pattern completely. Radio noise drifts constantly through open space, a soft static leftover from the birth of everything. This signal punches straight through that static. It arrives near 1420 megahertz, the exact frequency hydrogen atoms emit across the galaxy. Scientists chose that frequency years earlier as the most logical channel for a cosmic greeting. Hydrogen fills nearly every corner of the observable universe, making its signature frequency a shared reference point. A signal landing precisely there speaks with startling clarity. Physics itself seems to hand this transmission its accent. Your instinct says something this loud must return. Earth trains every mind on repetition. Rain falls and clouds circle back next season. Thunder cracks and storms revisit the same valley. Ocean tides retreat and rush forward again every single day. Every powerful event on this planet eventually shows a pattern worth tracking. That evolutionary shortcut convinces the brain that a spike this bright belongs to a source patient enough to catch again. Human survival for thousands of years depended on recognizing exactly this kind of repeating rhythm. Space breaks that rule completely. Hundreds of follow-up scans point back at that same patch of sky. Telescopes lock on to those exact coordinates near Sagittarius for decades. Bigger dishes, sharper receivers, and dedicated search programs all aim at the same small region. Each scan returns nothing but ordinary hiss and empty static. The signal refuses to reappear across nearly 50 years of dedicated listening. Astronomers chasing a repeat performance hunt a ghost built to appear exactly once. Their evolved instinct collides directly with a universe indifferent to second chances. Ghosts leave evidence behind anyway. Investigators drag every mundane explanation across that single sheet of paper. Spy satellites reflecting stray transmissions fail against the signal's steady duration. Comets passing through the field of view emit radio waves at entirely different frequencies. Orbiting debris catching sunlight cannot explain a beam locked onto the hydrogen line. Terrestrial interference gets ruled out because the signal's strength rises and falls exactly as expected from a fixed point in deep space. Each theory walks up to the data and cracks apart on contact. 6 characters in red ink outlast every rebuttal thrown at them. Big Ear itself deserves a closer look before the mystery deepens further. The telescope operated without the ability to point and track objects the way modern dishes do. Its design relied entirely on Earth's rotation to sweep its fixed field of view across the sky. A source drifting through that view would produce exactly the smooth rise and fall recorded that night. 72 seconds matches precisely how long a stationary point in space takes to cross the telescope's narrow beam. That timing detail alone rules out satellites moving on independent paths. You sense the weight of coincidence pressing against every explanation offered so far. Ohio State University originally designed the telescope to map thousands of radio sources across the sky. A dedicated project called SETI, the Search for Extraterrestrial Intelligence, later repurposed the instrument specifically to scan for artificial transmissions. Ehman's shift that August night belonged to this later, targeted phase of listening. Physicists Philip Morrison and Giuseppe Cacconi proposed the hydrogen line as an ideal contact frequency back in 1959. Their reasoning rested on hydrogen's status as the most abundant element across the entire universe. Choosing that exact frequency for a greeting would guarantee a shared reference point between two separate origins. Bandwidth becomes the loudest clue in the entire case. Natural cosmic noise typically smears across a wide range of frequencies. Pulsars, stars, and gas clouds radiate energy outward in broad, sloppy bands. This signal instead squeezes into an extremely narrow channel. It hugs the hydrogen frequency with a precision that startled the analysts studying it. Engineers building deep space communication systems often dream of exactly this kind of narrow, efficient signal. Accuracy this tight turns one datasheet into astronomy's most examined document. Your chest tightens the moment you picture that printout. Skeptics raised doubts almost immediately after news of the signal spread. Investigators specifically checked records for military and satellite transmissions active that same night. Nothing on record matched the signal's frequency, strength, or narrow bandwidth closely enough. Comet theories briefly gained traction during the 2010s among a handful of researchers. Careful analysis showed the frequencies produced by comets simply do not match the hydrogen line. That theory faded quickly once astronomers ran the numbers against archived orbital data. The mystery returned to its original wide-open state after each failed attempt at closure. Archived data from a different observatory entirely reopens the case in 2024. Researchers dig through decades-old records from the Arecibo Observatory in Puerto Rico. A magnetar sits at the center of their new proposal. This is a dead star crushed into a sphere 20 kilometers wide, wrapped in a magnetic field trillions of times stronger than Earth's own. These collapsed stellar corpses erupt occasionally in violent flares, releasing more energy in a fraction of a second than entire stars release over years. That flare slams into a cold cloud of drifting hydrogen gas. Impact forces the hydrogen atoms into a brief, synchronized state. This is the same physical principle that powers a laser here on Earth. Atoms lock together and release their energy in one coordinated burst. That burst produces a sharp, blinding pulse at exactly the hydrogen frequency. The cloud then relaxes back into its ordinary quiet state within seconds. A one-time flare, striking a one-time patch of gas, produces a signal that only ever happens once. This process, called astrophysical mazing, had already been observed in other cosmic environments before researchers applied it here. Scale collapses your sense of proportion here. Magnetars compress the mass of 1.5 suns into 20 kilometers. A teaspoon of that material would outweigh a mountain range on Earth. Magnetic fields inside a magnetar reach strengths that would erase a credit card from thousands of kilometers away. One violent hiccup from an object that dense mimics deliberate communication convincingly enough to fool trained astronomers for decades. Your hand hovers over that Arecibo readout, tracing the same spike Ehman circled in 1977. The realization lands with physical weight. The universe writes signals that look engineered purely through the ordinary behavior of dying stars. That fact relocates the wonder rather than shrinking it. Nature apparently speaks a language built entirely from magnetars and drifting gas. Satisfaction here still carries an important limitation attached. Proposing a plausible mechanism differs completely from confirming an actual source. No magnetar has been definitively identified sitting in exactly the direction the signal originated from. Confirmation would require finding direct evidence of a magnetar and a hydrogen cloud aligned precisely along that line of sight. Until that discovery happens, the magnetar theory remains the strongest candidate rather than a settled fact. Distance stretches this story across a scale your mind resists holding. Light covers roughly 300,000 kilometers every second. Certain candidate source regions still sit thousands of years away at that speed. A flare may have left its origin point before written human history began recording anything at all. 6 characters on a strip of paper compress thousands of years of travel into one shift at a small observatory. The line between artificial and natural blurs at this scale. Human intuition wants a hard boundary separating intelligence from raw astrophysics. That boundary dissolves the moment a dying star can counterfeit a deliberate greeting this convincingly. Nature holds the technical capability to mimic intention without possessing any intention at all. Every future signal detected from deep space now carries this same uncertainty baked directly into the analysis. You feel that uncertainty settle over the entire search for contact. Telescopes worldwide still point back at that same patch of sky today. Newer instruments scan wider bands, hunting either a repeat signal or definitive proof of the magnetar theory. Radio arrays across multiple continents now coordinate their schedules specifically around this one unresolved case. Every hour spent scanning that quiet corner of Sagittarius represents a refusal to let one mystery fade into old paperwork. Persistence, not certainty, stands as the actual achievement inside this 50-year chase. Adaptability defines the real triumph hidden inside this story. The WOW signal handed astronomers 0 easy answers on the night it arrived. Every dead-end theory forced researchers to sharpen their instruments and widen their thinking about what the cosmos can produce. That sharpened thinking eventually led directly back to archived Arecibo data decades later. Curiosity converted one unsolved puzzle into better tools built for solving the next unknown signal. Entire careers in radio astronomy trace their origin back to that one anomaly from 1977. Popular fascination with the case kept this story alive across 5 decades. Books, documentaries, and television specials return to those 6 characters again and again. Each retelling added its own speculation, some grounded in physics and some drifting toward pure fantasy. That constant retelling kept public attention focused on a story professional astronomy alone might have let fade. Public fascination with unresolved mysteries often translates directly into funding for new instruments. A single anomaly from 1977 continues justifying budget requests for telescopes built nearly 50 years later. Searching for cosmic company grows into something larger than a single event now. Modern radio telescopes carry the direct legacy of that August night in 1977. Engineers built sharper receivers specifically because one overlooked anomaly proved how much a single signal can matter. Future missions plan to monitor far more sky far more often, catching transient flashes older instruments would miss entirely. Every upgrade traces its motivation back to 6 characters and one word written in red ink. Every answer this signal produces opens a wider question behind it. A magnetar flare striking hydrogen gas explains the mechanics beautifully on its own. It immediately raises a harder question nobody has settled yet. Countless other transient flashes likely sit buried in decades-old archives, waiting for someone to notice the pattern Ehman noticed first. The universe produces far more one-time events than repeatable ones across its entire lifespan. A search strategy built around waiting for repetition misses most of what space actually says. Silence in follow-up data marks a fading trace, not an absence of activity. You carry that lesson forward into every future search for contact. That printout still exists today, preserved like a fossil of one cosmic moment. Researchers still travel specifically to examine the handwriting circling that single anomaly. 6 characters and 1 exclamation continue drawing fresh eyes into old data every single year. 2 truths sit side by side inside that page. The universe may hold no other minds capable of sending a deliberate greeting toward this small planet. It may instead speak constantly, in a dialect built from magnetars, hydrogen clouds, and the raw physics of dying stars. Humanity reads one anomaly at a time, learning that dialect, one flare, one archive, one red-inked word at a time. Every telescope built from this point forward carries that same patient curiosity pointed back toward Sagittarius.